Okay, while I'm on this problem, I do want to talk about a little bit about notation here. And you can see that I wrote over here that the original function was y equals x cubed. But actually this problem is working with the function in function notation. It's writing it as f of x and not really concerned with what the actual function is. So what I wanted to do is write what the function would look like so you can see a comparison between the two if we were writing it in y equals x cubed form. And so that would be x minus 1 cubed minus 2, which actually I do need to make a correction to this. This is not y equals x cubed, this is y equals negative x cubed. So I'll put that over there in red so that you make sure you see actually y equals x cubed would be a reflection of that either around the x-axis or the y-axis, and not what it's not x cubed but negative x cubed. And so that would make our function negative quantity x minus 1 cubed minus 2. With the second one, with b, that would be negative quantity x minus 1 cubed plus 2. With c, that would be negative quantity x plus 1 cubed minus 2. And with d, that would be x plus 1 cubed, negative x plus 1 cubed plus 2. So you may not be able to see, I think you can see how they are similar to each other in many ways, but yet at the same time it may not be so apparent why they are really the same thing. And so what I wanted to do is show you on the calculator what this might look like. So I have a copy of the TI-84 there showing the original function, which is y equals negative x cubed. Now what I want to do with this instead is to work with this in functional notation to see if it makes sense to you. And this might also help you to learn something about the calculator as well. So the first thing that I want to do is I want to turn off that y equals negative x cubed, or the y1 function. And the way that I do that is I move the cursor up onto the equal sign and I hit enter. And notice how it's no longer, and then enter again. Well, I need to move it off and hit enter. And you can see now that, well, it's still back on. Hold on a second. So I move up to the equal sign, I hit enter, and now it's no longer highlighted. I move over one space, then hit enter again, and now the first function is not highlighted. In the second function, what I'm going to do is I'm going to go to variables, which is vars, yvars, and function. What this allows me to do is to use the original, or the y1 function. What this also allows me to do is to use some functional notation. So I put parentheses and I'm going to put x minus 1 and then minus 2 in there for the second function. And when I go to graph this, you should see variation A, or letter A, which we basically do see there. Alright, so what I did was, instead of using x minus 1 quantity cubed, or negative x minus 1 quantity cubed minus 2, I left it in functional notation. And if I go back to the function definition, then you can see how that's y1 is kind of like f of x minus 1 minus 2, assuming that f is defined as negative x cubed. And we can do the same thing with the others. I'm going to do them real briefly. First turning off y2, and now starting with y3. I want to do vars, yvars, function, y1, and this time I put in y1 of x minus 1 and then plus 2, and you can see that its graph looks like letter B. We'll go back. This time it's vars, yvars, function, y1 of x plus 1 minus 2, and when I graph that you can see letter C. Finally, I do vars, yvars, function, y1 plus 2, and that should give me letter D. And there you have it. So this is a way that we can use functional notation on the calculator, and hopefully you've learned a little something that helps with this problem.